One method for determining blood pressure is to listen with a stethoscope to the sound of blood as the pressure applied by a cuff to a person's arm is reduced. What causes the sound heard? Now, this is an informational example, but I included it because it's an interesting example that many of us have maybe had our blood pressure measured and maybe somewhat familiar with how it works, and relates to turbulence. I don't know if it relates as directly to Reynolds number, but it relates to turbulence. And the simple answer is what causes the sound heard is turbulent flow. And I'm going to draw here, because usually what happens when your blood pressure is measured is pressure is applied through a cuff, right? As it says there. But that it's brought up to higher pressure, and then if it's done manually, that is, the pressure is slowly released while the person listens, or the nurse or whoever is listening, to your blood flow with a stethoscope, usually right around the place where the cuff is on you, right? So what's happening? So I'm going to draw kind of an arrow here, and this arrow is going to represent sort of the progression from the initial high pressure applied by the cuff that is slowly let off and gets down to low pressure. And we're going to talk about kind of what happens as it does that. Well, at a certain point, the person listening through the stethoscope will start to hear some blood getting through. Basically, at high enough pressure, no blood is getting through the artery in your arm, the main artery that's there. But as the pressure is let off, some blood starts to squeeze its way through, but it's only intermittent. Basically, it's only getting through when the heart is pumping, or when the heart pumps. In other words, when the heart is applying the most pressure to your vascular system. And that it corresponds to the systolic pressure. So I'm just going to put the word systolic here. And then as the pressure lowers, they'll continue to hear that intermittent turbulent flow. But at some point, the sound disappears. And the reason why is because at a certain point, that pressure becomes low enough that the artery is no longer closed in between pumps. So at that point, that's the pressure that really corresponds to kind of the resting pressure of the system, or that's when the heart that is resting. In other words, the pressure between beats, or what is sort of the, you could also say the background pressure, I guess. And that is since that corresponds, I always think about this since the heart is kind of, I guess, dilated, so it's the diastolic. Let's see, hang on. Diastolic pressure. This is why I stay in physics most of the time. So, and so usually when you get your blood pressure, measured, you might, maybe you've if you're really healthy, I think you might have 110/70 or something like that, or 120/80 is like the cutoff for hypertension, right? Let's look at the answer here. It says the sound corresponds to turbulent flow of blood. At the systolic pressure, the sound starts, and that's what I was describing here, as the pressure gets just low enough for blood to get through intermittently. The sound vanishes at the diastolic pressure, where the intermittent turbulent flow stops because the pressure is low enough for blood to flow through continuously. So basically past this point, that's where blood is able to flow through the artery that has the, still some pressure applied by the cuff, but it's able to do that, through the whole time, which means one way to think about that is it means that the overall flow rate can be lower because it's able to flow the whole time. And since now the flow rate is lower, that's kind of how the transition goes from turbulent to laminar, because there is a lowering of the Reynolds number that corresponds to this point right here.